Hi everyone, in 1.1 we're going to start looking into finding antiderivatives. And antiderivatives are appropriately named. They are basically the opposite of derivatives. So in terms of performing an operation, differentiation and antidifferentiation are inverse operations. So if we're looking at a function and we're trying to find its antiderivative, we're asking ourselves what function would we take the derivative of to get the thing that we're looking at. So we know that we have an antiderivative if we take its derivative and get the function that we started with. Okay, so this preview, I'm going to run through the first one. This is going to go back to what's hopefully really comfortable for us, taking derivatives. And then we are going to just reverse the wording on that to talk about an antiderivative. So here, just as a reminder, when you get something like square root of x, you'll want to rewrite it as x to the 1/2. And then the derivative will be a power rule. Okay, so there's my derivative. So we know that, and I'm going to rewrite it a little bit, 1 over 2 root x is the derivative of the square root of x. And you don't have to rewrite that as a 1 over 2 root x, but I, in general, don't want negative exponents in answers, so putting that in the bottom would be good. We can also, okay, so we know that 1 over 2 root x is the derivative of square root of x. This means that we can say that the square root of x is the antiderivative of 1 over 2 root x. So if you are looking at 1 over 2 root x and you know that you have to take the derivative of square root x to get that, then square root x is its antiderivative. At this point, it would be great if you would pause and see if you can work through the rest of these on your own really quickly, just to make sure you're getting it, and then check back in. So the derivative of tangent, okay, so this is another, we just want to make sure we're really good with our derivative shortcuts. If you're feeling rusty at all and need more practice, let me know, because you want to be really good with those for this class. So we know that secant squared is the derivative of tangent, which means that we can say that tangent is the antiderivative of secant squared. Tangent is the function we take the derivative of to get secant squared. Okay, derivative of 2x squared, so that's going to be a power rule. We're going to drop that 2 down in front and get 4x to the 1 is the derivative of 2x squared, which means that we can say that 2x squared is an antiderivative of 4x. Okay. Let's see, 2x squared minus 1. Okay, so we're going to start off with that same power rule, 4x, and then the derivative of 1 is 0, so just that is the derivative of 2x squared minus 1. So we can say that 2x squared minus 1 is an antiderivative of 4x. Okay, so notice we've now made two different claims. We've said that 2x squared is an antiderivative of 4x, and 2x squared minus 1 is an antiderivative of 4x. And I was very deliberate about picking this "and" here, because what we're starting to see is that there's not a single unique correct answer to this thing. So let's do one more, and then I'll summarize that part. Okay, so here, 2x squared plus 5, we've got that same power rule showing up again. We get 4x plus 0 is the derivative of 2x squared plus 5, which means that 2x squared plus 5 is an antiderivative of 4x. Okay, so if we want to, basically what we've done here is picked out one function in each of these that's an antiderivative. If we want to give a little bit more complete answer, give the full story, what we're going to have to do, and you can see this definition on the top of the next page, is actually allow for that constant that disappears when you take the derivative. So it's not a constant multiplied by our function, it's a constant added on to our function. So I would say here that my more complete answer is 2x squared plus c is the antiderivative So again, that the is important. The antiderivative of a function is not a single function. It's going to be a family of functions who only differ by this plus c. So c here can take on any real number value. It can be a positive 5, it can be a negative 1, back up here, it could be 0, it can be any real number. And what that represents graphically is vertical shift. So really what we're claiming here is that if you shift a graph up or down, a graph, you're not changing the slopes at a given x coordinate. So a function relates y values to x values, a derivative relates x values to slopes. So here, again, this is not a very perfect picture, but if we pretend, we're saying if we pick a single x value, the slopes for our tangent lines would be identical if the only difference is vertical shift. Okay, so that's the intro for antiderivatives. Thanks for watching.